Good day, learners. I am teacher Jessica Alcaraz Sungguad, your teacher in statistics and probability. We are in quarter 3, week 8, and for week 8, we will be talking about length of confidence interval and sample size. There are 4 learning competencies for this week, which can be seen in your learning activity sheets. To explore, you're going to find the range of the following set of data. Write your answer in your notebook and check your answer with the answer key at the end of the activity sheet. Definition of terms: confidence interval. In statistics, this refers to the probability that population parameter will fall between a set of values for a certain proportion of times. Confidence intervals measures the degree of uncertainty or certainty in a sampling method. They can take any number of probability limits, with the most common being a 95% or 99% confidence level. Narrowness of the interval. This pertains to a small width in relation to the length of the confidence interval. Length of confidence interval. This refers to the absolute difference between the upper confidence limit and the lower confidence limit. So for the formula, you have LCI equals the absolute value of UCL minus LCL equals the absolute value of LCL minus UCL, or LCI equals UCL minus LCL. So where LCI is the length of confidence interval, UCL is the upper confidence limit, and LCL is the lower confidence limit. Let's have example number 1. Find the length of the confidence interval of p greater than 0.275 but less than 0.360. So for the solution, your LCI is equal to the upper confidence limit minus the lower confidence limit. So you have there 0.360 minus 0.275, and that is equal to 0.085. Thus, the length of the confidence interval is 0.085. So for number 2, find the length of the confidence interval mu greater than 0.526 but less than 0.805. So for your solution, LCI equals UCL minus LCL equals 0.805 minus 0.526 equals 0.279. So thus the length of the confidence is 0.279. The formula for interval estimate of population mean with known variance is mu greater than mean minus z sub alpha over 2 times standard deviation over square root of n, but less than mean plus z sub alpha over 2 times standard deviation over square root of n. The formula to find the length of the confidence interval is LCI equals 2 times z sub alpha over 2 times standard deviation over square root of n, where z sub alpha over 2 is the z value, sigma is the standard deviation, and n is the sample size. So we have commonly used z value with the confidence level of 90%, 95%, and 99%. So our alpha for 90% is 0.10, for 95% is 0.05, for 99 you have 0.01. So if we're going to look for the value of z sub alpha over 2, so for 90%, that is positive negative 1.65. For 95%, you have positive negative 1.96. And for 99%, you have positive negative 2.58. So take note, guys, that the z value is z value of z sub alpha over 2, meaning you divide your alpha by 2. So let's have example number 1. Find the length of the confidence interval. So given that your sigma is 0.3 and it's your 70 and the confidence level is 95%. So for your solution, so identify the given. So sigma is 0.3 and is 70. From the confidence level of 95%, your z sub alpha over 2 is 1.96. So with that, your LCI is equal to 2 times z sub alpha over 2 times standard deviation over square root of n, You substitute the given to the uh, formula. So you have there 2 times 1.96, which is your z sub alpha over 2 times 0.3, which is your sigma, and over square root of 70, which is your n. So that would be just equal to 0.1406. Now you might be wondering how to obtain that value. You just made use of a scientific calculator, and I'm warning you, you have to use appropriately the grouping symbol so that you would arrive to the correct answer. So with that, you could say that the length of the confidence interval is equal to 0.1406. Now you might be wondering why we did not discuss about the interval estimate. So the first formula that I have mentioned, it is because in this uh, learning activity sheets, we're just focusing on the length of the confidence interval. Why did I include the interval estimate? In case you wish to compute for the exact value of the upper limit and the lower limit, you can use that formula. The formula for confidence interval of population mean if n is less than 30, you have mu greater than mean minus t sub alpha over 2 times standard deviation over square root of n, but less than mean plus t sub alpha over 2 times standard deviation over square root of n. The formula to find the length of the confidence interval is LCI equals 2 times t sub alpha over 2 times standard deviation over square root of n, where t sub alpha over 2 is the t-value, sigma is the standard deviation, and n is the sample size. Let's take a look at this example. Find the length of the confidence interval given the following data. S equals 6.5, n equals 15, confidence level is 99%. So our given is the standard deviation equals 6.5, n equals 15, and the confidence level is 99%. So since n is 15, so our degrees of freedom is n minus 1, so that is 15 minus 1 equals 14. For 99% confidence level, our alpha is 0.01, so alpha over 2 is 0.005. Now locate the t-value using the t-distribution with degrees of freedom of 14 and alpha, which is 0.05. So with that, our t sub alpha over 2 is equal to 2.977. So our LCI is equal to 2 times t sub alpha over 2 times standard deviation over square root of n. So that will give you 2 times 2.977 times 6.5 over square root of 15. So using your scientific calculator with the correct grouping symbols, that will give you 9.9926. So therefore, you can say that the length of the confidence interval is equal to 9.9926. The formula for computing a large sample confidence interval for a population proportion is given by p greater than p hat minus c sub alpha over 2 times the square root of p hat times q hat over n, but less than p hat plus c sub alpha over 2 times the square root of p hat times q hat over n. The formula to find the length of the confidence interval is LCI equals 2 times z sub alpha over 2 times square root of p hat times q hat over n. For a sample proportion, your x is the number of sample elements that possesses the desired characteristic. Your c sub alpha over 2 is the z-value. Your n is the sample size. Your p hat is the sample proportion, read as p hat. Your p hat is equal to x over n. So if you're not given with the exact value of p hat, that is just simply x divided by n. And your q hat is 1 minus p hat. So let's take a look at this example. Compute for the length of the confidence interval using 95% confidence level of the proportion of household that practice good trash management with x equals 236 and n equals 458. So our solution is we have the given x equals 236, and N is 458 and 95% confidence levels. So thus our C sub alpha over 2 is equal to 1.96. So for your p hat, that is x over n. So you have 236 divided by 458, and that is equal to 0.52. Our q hat is equal to 1 minus p hat, and that is equal to 1 minus 0.52. That will give you 0.48. So our LCI, you have 2 times d sub alpha over 2 times the square root of p hat times q hat over n. Substituting the given to the formula, you have 2 times 1.96 times the square root of 0.52 times 0.48 divided by 458. And using the correct grouping symbol, you can press the given to your scientific calculator. That will give you 0.0915. So therefore, you could say that the length of the confidence interval is equal to 0.0915. For the sample size, you have the formula for the margin of error. So you have E equals C sub alpha over 2 times standard deviation over square root of n. E denotes the margin of error. Z sub alpha over 2 is the confidence coefficient. Sigma is the population standard deviation. And n is the sample size. So our formula in determining the minimum sample size needed when estimating the population mean is equal to is n equals the quantity g sub alpha over 2 times standard deviation over e squared. So the formula in determining the minimum population sample size needed in estimating the population proportion is given by n equals p hat times q hat times the quantity z sub alpha over 2 squared. Since the value of the standard deviation is usually unknown, it can be estimated. Alternatively, we may approximate the range of observation in the population and make a conservative estimate of R over 4. In any case, round off the value of obtained to ensure the sample size will be sufficient to achieve the specified reliability. Let's have example about feeding program. In a certain barangay, Mario wants to estimate the mean weight in kilograms of all 7-year-old children to be included in a feeding program. He wants to be 99% confident that the estimate of mu is accurate within 0.06 kilogram. Suppose from a previous study, the standard deviation of the weights of the targeted population was zero point 0.5 kilogram. What should be the sample size? So from the given, you have sigma equals zero point 0.5, b equals 0.06. In a confidence level of 99%, thus our C sub alpha over 2 is equal to 2.58. So substituting the given to the formula, which is n equals the quantity C sub alpha over 2 times standard deviation over E, you would have the quantity squared of 2.58 times 0.5 divided by 0.06. So that would be equal to 1.29. You just multiply 2.58 times 0.5 divided by 0.06. So that would be equal to 21.5. You divide 1.29 by 0.06, so you have 21.5. So squaring 21.5, that would give you 462.25. So therefore, the required sample size is 463 7-year-old children. So why is it that you have 463? So we run up, since we are talking about sample size, we round up our obtained value to the next whole number. So that is why you have 463. Another example about detergent X. Mary wants to know with 95% confidence the proportion of household who like to use detergent X. A previous survey showed that 42% like to use detergent X. Mary likes to be accurate within 2% of the true proportion. How many sample size does Mary need? So from our solution, you have the given p hat equals 0.42, q hat is 1 minus p hat, so you have 1 minus 0.42, that is equal to 0.58. and your E is equal to 0.02. So for the confidence level, which is 95%, our Z sub alpha over 2 is equal to 1.96. So substituting the given to the formula, which is P hat times Q hat times the quantity squared of Z sub alpha over 2 over E, that will give you 0.42 times 0.58 times the quantity squared of 1.96 divided by 0.02. So with that, you would have 0.42 times 0.58 times 98 squared. So where did we get 98? So that is from 1.96 divided by 0.02. So squaring 98, so that will give you 9604. So multiplying 0.42 times 0.58 times 9604, that will give you 22,339.53. So we round off our answer to the next whole number, that would give you 2,340. So therefore you could say that Mary needs a sample of 2,340 respondents. So you have to take note that when determining sample size, we always round up the resulting value to the next whole number. So our rule is when the calculated sample size is not a whole number, it should be round up to the next higher whole number. For the English, you're going to answer this one in your notebook. You can check your answer with the answer key at the end of the activity sheets. For letter A and letter B, you're going to find the length of the confidence interval. For letter C, you're going to find the sample size. For the apply, which will serve as your assessment, you're going to answer 10 items multiple choice test. For numbers 1 to 5, that is 1 point each. For numbers 6 to 10, that is 3 points each. You have to show your solution. Take note again, avoid copying from your classmates. That's all for week 8. Thank you and God bless.